Hi. The topic for today's discussion is continuous integration with Jenkins. Today we'll briefly discuss what continuous integration is all about, what principles it lays down, how it improves the software delivery process, and how we can achieve these benefits with the help of tools like Jenkins. So the agenda for today's discussion would be as follows. We will start with a brief introduction about continuous integration. What are the benefits, where it is applicable, what kind of principles it has, why it is needed for a faster software delivery these days. And then we will move to an introduction of Jenkins. We will set up Jenkins on a local environment using Docker. Docker is a beautiful way to have a software running on your system within no time. And then we will navigate within Jenkins to see what all dashboards it has, how we can integrate our code repositories with Jenkins and basically achieve continuous integration. At the end of the demo, we should have a Jenkins build pipeline, which would have various stages, and those would be triggered as and when new code is pushed to the repository. So if we talk about 2018, this is how the software delivery process looks like. So the entire life cycle of making a code commit, building it, running the unit tests, and deploying it. This should be done in 10 minutes. That is what the customers expect these days. That is what the end users expect these days. Amazon does a code deploy every 6 minutes to production systems. Now, when we consider such time constraints, it becomes very important to have solid pipelines, solid automation, solid testing, and solid integration processes in place. Because even the software teams are big these days. There are a lot of developers working from remote locations, working from different areas on the same code repository. And there has to be some mechanism in place which integrates all of their code, validates that against a master test suite, integrates their code, does some basic testing, and reports back with the feedback to the end users that if the build is working fine or not. If I remember one of my experiences in 2011, back then I was working on a Java based project. It was just a Maven based Java project. And if I remember, the production deployment that we used to do would take close to 1 hour because we used to just build the jar file on our local systems, copy it over to a remote server, and if the build has to be copied over to different servers, then we would trigger the copying functionality one by one, and that was a big manual painful process. And then we had new features come in, and it was like copying Java class files over different servers and getting the code running. It was really painful because we didn't have a continuous integration, we didn't have the continuous testing pipeline in place. So most of the errors won't occur on our dev systems, but they would show up on production systems because there was not a feedback loop that was present whenever one of our development team members checked in code. And those are basically the challenges what continuous integration plans to solve. It is not a new concept. It is in use by companies from a long time. And this slide basically lists down the core principles that continuous integration lays down. It says that the software development practices should be centered around a single master branch. And that is where frequent commits should be made by all the developers. What this means is that there should be one particular branch wherein you can at any moment of time say that this code, whatever is there in this branch, has been tested and is ready to be deployed. If this branch becomes unstable due to any of the recent changes, then the developers' first focus or first criteria or the top priority has to be to fix those bugs or introduce the fixes for removing those bugs in no time. And then the main idea behind this is whatever code you are developing, The idea is to fail fast, so that it is not that I will do development on my local machine for one big month and then share my code on a central repository. It is still fine if I'm the only developer in the system, but what if there are 10 different developers? Now, 10 different developers might be working on changes which might conflict with each other's code. So then they need to push changes incrementally into a centralized repository, and an automated tool or framework like Jenkins should take over from there and provide feedback to the software team members that the code is working fine or not. And it mainly focuses on the working code in the repository. This is very important here. So if the code is not working in your master branch, somebody has to look into it, because this would be the this would be the point where your code would have started diverging, or there might be some conflicts with the code which different developers might have introduced. And it is always better to fail fast to fix these issues early, because when 10 developers integrate code in the end, it will become a pain, and moreover you would be close to the development close or the release cycle during that time. And we should always aim to establish a daily CI process, a daily continuous integration process, wherein something can do nightly builds, something can do on demand testing of your code, and things like that. So the benefits, as I talked about, are mainly on the lines of faster bugs detection. So as quickly as you push code to a centralized repository, something can test it faster. And it also has the additional benefit that you basically get you're saved from hardware failures or machine failures, because if you're keeping the code which is not pushed to a centralized repository on a daily basis, you are at risk of losing that code if something goes wrong with your hard disk or any other hardware failure. And developers, most importantly, adopt an incremental mindset with continuous integration. They need to understand that the software delivery process is a lot more agile than how it used to be some 5 or 10 years back. And it is very important to code smaller features and release them to production systems by thoroughly testing them. And that is what end users expect these days. We see a lot of features on Facebook, on the Amazon shopping console. We see that a lot of features are daily introduced and a lot of changes are done to those systems, but we hardly see any downtime, right? And that is because they have a solid continuous integration and continuous delivery and deployment processes in place. And now moving further, we will briefly talk about Jenkins. It is an automation server which supports building, deploying, and performing tasks for software projects. It is written in Java. Previously, it was called Hudson. And a few years back, the main project was then forked into an open source project called Jenkins. And the source code is available at this link. And the main power of Jenkins lies within the plugins. We will shortly see that for various different tasks, we can just install a plugin and it just works out of the box. That is that is the idea behind a tool like Jenkins, that the core code of the application is very small, is very lightweight, and then you can customize or inject custom plugins based on your need. So everybody need not have a monolithic big bang Jenkins installation for their production systems or local development environments. They can customize it to their needs. So now I will briefly walk you through the various steps to have Jenkins up and running on your system. So now I'm on my local terminal on my machine. So here we will see how we install Jenkins as a Docker container. Now, for all those who are not aware of Docker, it is just a containerization framework which helps you bring up Linux containers. Containers are nothing new to the Linux world or the other Unix world per se. We had containers in Solaris in terms of Solaris zones. We had Elixir containers in the past. Docker has just made working with those concepts easier. That's all. even without Docker, you could pretty much be working with containers. So moving ahead, I can just list down the Docker images. Docker images are nothing but sort of artifacts, layered file systems, which basically contain the changes that collectively bring up your process and have it running on your system within a few seconds. So we will be using this first image, Jenkins CI/Akshay. So in this, what we need to pass in is a port. This is what will be. This basically defines what traffic from the host machine, that is my local VM, would be forwarded to the remote port, that is which is inside the container. And similarly, we have another port. So these ports are defined by the Jenkins official Docker image, and this is where the process would be running inside the container, and that is why we are redirecting traffic from the host machine to inside the container. Now here I can just pass in the Docker image name. So once this is running, basically it returns a UUID. So at this point of time, we have the Docker container running. So we can see with the Docker PS command, like we have a process status command in Linux. So here we see the container ID, we see the image, and we see that it was created less than a second ago, and its recent status, it is up and running. And these are the port forwardings that we passed in the Docker command line. And if you don't pass in an explicit name, Docker just gives a random name combination for your container, making it unique across this machine. So now, since the container is running, we can just go to the browser, and here we can run 8080 port localhost. So if I press enter, we will see that it has brought us directly to the getting started page for Jenkins. This is the Jenkins installation page. At this point, we are on the localhost 8080 page that you can see in my browser address bar. And we are on the getting started page. This is the installation page for Jenkins, and it is asking for an administrative password. For the password, we will go back to our terminal, and as we listed down the container ID before, we will see that we just got, if I pass in the docker logs command and just pass in the container ID to this one, it just prints out the console log for the application running inside the container. And then what I could do is, since the output comes on the error stream, that is the standard behavior with most of the CLI tools, we redirect to the output stream, that is one, and then I do a grep on I basically want to search from the entire logs the initial password which was emitted as part of the process when it was coming up. So here I basically just use -i for ignore casing, and then I pass in initial admin password, and wherever this matches, I want to print 10 lines after that and 10 lines before that. So searching for this, we have this output on our screen. Basically, this is what was emitted by the process when it came up. So we can use this. There's the admin password, which we will now use in the browser to configure Jenkins. And just to ensure that you are not confused with the above command, so I did a docker ps, I copied the container ID, and you could have pretty much done docker logs this container ID, and it will give you all the logs. But then since these were this would have been a lot of data that we would have gone through, I just did a search on these lines. That's it. So now I will basically just copy this password, go to the browser, copy it here, and press on continue. So now Jenkins is loading up, and as we discussed, Jenkins core software is very lightweight. It doesn't have all the frills attached, doesn't come with those, but you can always install the plugins, keeping in mind or considering what type of projects, what type of executions you want to do inside Jenkins. So I can click on install suggested plugins here, and these are the basic plugins that Jenkins installation most of the time needs, because we deal with Git, code repositories, or we deal with subversions, or we have some build management frameworks like Ant, and Jenkins might often want to SSH into a remote machine. So that is why we have the SSH plugins. We have the build timeout. We have LDAP integration. For example, you want to integrate Jenkins login with the LDAP within your company. You could also do that. And then we have the pipeline plugin, which we will be using in the demo in some time. And this will take some time, all the plugins to get installed. Once the installation of the plugins is complete, basically Jenkins lands us on this page where we need to create our first admin user. At this point, I would also like to mention one thing, that like we saw the Docker containers that were running on the system, you could also do a docker logs -f and passing in the container ID. -f is for the tail option, wherein you can just watch the logs as and when they're coming, and this would have given you a good idea of what plugin installations are being done, and downloading PM authentication, downloading LDAP, and how it installs those plugins. So whatever goes on in Jenkins, you can always monitor the logs using these commands. Just a handy tip if you somehow cannot understand what Jenkins is executing at the backend and you want to dig further. So going back to the Jenkins screen, I'll create my first admin user. And here we can click on save and continue. This is the Jenkins URL, which basically defines the main URL, and all the job names and further things will be appended as URL parts further to this main URL. So now Jenkins is ready and we can start using it. So it doesn't have any jobs as of now. So this is how the Jenkins dashboard looks like. So on the left side, we have a panel, a new item, basically the Jenkins configurations, whatever we add can be a job, can be a pipeline, and those are the items which this thing denotes. We will be using it shortly. And then we have something like people for all the users that are using Jenkins. We have build history, and we can use manage Jenkins to install plugins. We will also use this option in short time. And then we have views. Views are something where you can customize your dashboard to see a specific subset of jobs that you might have configured. For example, in the Jenkins you have 100 different jobs, but 10 of them attend to one specific need. Then you could also club 10 of those in one separate private view, just to have a clear understanding of those 10 different jobs. And similarly, we have credentials and new view, which are self-understandable, self-explanatory. So now we will go ahead and click on new item. This is the first job where we will set up the integration with the GitHub repository that we have. So for the demo, I plan to use this repository, which is a simple Java Maven app. And this is a fork of the official repository that is on the Jenkins docs website, Jenkins docs GitHub repository. So I've just created a fork from there, done some minor changes, and we'll go through that in a short while from now. So for the purpose of configuring the Jenkins job, I'll just copy the URL for this GitHub repository, go back to the Jenkins job, and here we can have a first job, which is compile. So this will be a freestyle project, and then I click on OK. So item name, as I mentioned here, these are all the items that I could create in Jenkins. So this is the compilation job for the Maven Java app application. And this is a GitHub project. So basically right now I'm on the configuration page. So here we have different tabs. We have source code management, we have build triggers, what would trigger this job. We'll see at those we'll see those options. And then we have build environments and build and post build actions. So Jenkins essentially is a software which is sort of a middleware which integrates both side of things. One is your code repository, and the other side of the things is what you want to do with any changes that might have happened on that repository. So here in the GitHub project, I will just copy the GitHub project URL, and then we can go to source code management, where it asks what type of code repository this is. Is it a Git managed or subversion managed? And here I can click on Git. I can copy the repository URL here again, and branch can be master because all the code is in master. And I could these are basically the build triggers, which where you can define some custom behavior. You could ask Jenkins to watch the GitHub repository, or you could tell GitHub that let Jenkins know whenever there's a code change and we want this job to be triggered. So that requires some additional configuration. So for the sake of demo, we will restrict to Jenkins asking for code updates from GitHub. Polling is something which you could also enable here. Polling in polling, Jenkins keeps on polling the GitHub at a predefined interval, but when they're but between polling and pushing, you normally have to take you normally need to consider one of these, and that depends on what type of or what amount of code actually goes in your repository. There are a lot of developers, there are frequent check-ins of code, there are frequent commits coming on your repository. Then something like polling is preferred, because you don't want GitHub to trigger Jenkins jobs that frequently. And yeah, so that could be a decision that you can always make in future. For now, we will keep these options unchecked. And now we can just add a build step, and we can invoke a top level Maven target, and here I can just write compile, and that's all. So with this job, basically Maven target compile will be triggered when I run this job, and we'll see how it works. I'll click on apply, I click on save, and this job is ready. So if I go to the Jenkins dashboard again, previously it was showing create new jobs, and now we have this first job which is running here. If I click on compile and then I click on build now, it basically triggers a new job which pulls code. I can check what it is doing by clicking on this bar, and here it says that okay, I'm pulling code from the repository, and it did a checkout of this particular revision. So if I see here, there's the same commit 01C48E3, and same code was pulled in by Jenkins, and now it checks the POM file on what all plugins have been configured. So that is why it is doing a Maven compile. When it did a Maven compile, it scanned the project, checked the pom.xml file, which defines the structures, which define the plugins that are used by the project, and now it is downloading those. So once these are done, we will have a compilation success or error of this code that is there on the repository. So this will take some time, and while this happens, I would also like to focus on one other concept here. So if I log in, now docker exec is a command, is a Docker command to run run any other command inside the container. So here I can pass the container ID as the parameter, and then I can pass what. So I need a bash shell inside the container. This is the way to log in inside the container. And here basically I want to show you how or where Jenkins actually places those files. So this is the Jenkins home directory. Inside that we have the workspace folder. Now whatever projects we create are basically created as a subdirectory inside the workspace folder. Now if I go to compile, I will see that Jenkins has cloned the entire code repository at this disk location. If we check the GitHub repository, these are the files that we see. and we have the latest commit 01C48E3. We will just verify that this is the same commit that Jenkins is working on, and yes, it looks same. So this is how it works. And once it has cloned and it has access to all of these code files, then it executes the further commands that we have mentioned in the job. So going back to the Jenkins job, we see that the build has successfully finished and the compilation was successful. So with this, we have our first job running, the compile job for this particular GitHub repository. So now since the compile job is up and working, now we can go ahead and add another freestyle project, and let's name it as test. And what I intend to do here is, like, a Maven based project has various targets, various top level targets or actions that I can trigger. Previously we did compile, and now it will be test. So if we quickly go to the repository, and there we can see that as part of the code, some unit tests have been defined. So when developers are making changes to the code, it really helps to validate all those changes against the unit tests that have been written. So whatever unit tests are there inside this file as part of the Maven test action, those will be triggered and it will be verified that the code still functions as expected. So let's go ahead and create this project. This is the test. And here again, we can define the GitHub project, and I'll just copy the repository URL for this one and paste it here. And yes, this is again a Git repository, get controlled by the Git version control. And then the next thing that we need to do is we need to define a build step, which will again be a top level Maven target, and here we can define test, and then we can click on apply and save. So now we have the test project just like the compiled one, and let's go ahead and trigger a build for this one. So initially what this will do is it will clone the repository, look for the POM file, check how the unit tests have been defined, and go and execute them. So while this runs, similarly we can get inside the container and see that, okay, previously we were in the compiled folder under the workspace directory. So now if I go back, I can see that the test directory has also been created. So if we go inside this and check, we can see all the files that have been cloned from the repository, and at this point Jenkins would run, and we see that the build is blue, which is for success. We'll just go and check the output. So it says that so initially it tried downloading some plugins as part of the test action that it needed to execute, and once that was done, it proceeded ahead with the unit tests, and which basically ran for two definitions. Time was this much and failures was 0, and all was success. So this really helps us helps developers with the confidence that they need, that any changes that they have recently introduced didn't break anything that might have occurred in the past. So it is really important that unit tests are also written in parallel to any new code that is integrated into your repository, and it is always a good thing to have a high level of unit test coverage, ideally 100%. And now since this is done, let's go ahead and create another job. So why I'm creating out these jobs is because these are independent projects which test some aspect of the project code some aspect of the code that is there in the repository. We tested the compilation is working fine. We tested that the unit tests are working fine. Now we'll create a coverage report. And why we are going through this path is so that in the end, we can club all of these builds together into one single pipeline, which gets triggered as and when some new code is pushed into the repository. So that is how we can start using continuous integration principles and achieve the benefits out of it. So all the developers need not run all of these jobs or all of these Maven actions on the local machines. Rather, they can pretty much depend on the tooling and the automation that is provided by Jenkins here. So before we go ahead and create the third job for triggering the coverage report, what we can do is we need to go to the manage Jenkins link, and from here we can define the Coursera plugin, basically, which helps us create or generate the coverage report. So we can just click on the available tab, and here I can just search for Coursera. So just click on this one and install without restart. So at this point, it will download all the dependencies from the Maven repository for Coursera. So it looks like there is some failure. Probably the mirrors .jenkinsci.org, this didn't resolve. So what we can do is I could try creating this, installing this plugin again. Might have been caused by some temporary network issue. And we'll try installation again. So it still fails. Okay, so it was just a temporary network failure. So I basically restarted the Docker container, and then we see that the plugin installation has now succeeded. At this point, we can go ahead and create a third job for basically checking the test coverage and also publishing the report on the project page. This can again be a freestyle project. Okay, and just copy the repository URL. And here we can again click on GitHub project and define the URL to the Maven based Java application. And now we can click on Git source code management and have the URL of the repository in this field. At this point, we can define post build action, wherein we can publish a Coursera coverage report. And before that, we would also need a Maven target to define the Coursera report execution. So here what I'm doing is I'm defining the Coursera action and just passing in a variable to the Coursera report execution, because we need the format of the report to be XML. So once this is done, now it is basically asking us for the target location of the XML file once it is created. So we can have this as target site Coursera coverage.xml. And just I'll show you inside the Docker container once this project is run, and inside the target folder for the GitHub repository, it will create this coverage report, and that is what we will use to upload to the project homepage. Now we can click on apply, and save. At this point, you can click on build now, and we will see that a build has triggered for this project. It will again scan the pom.xml file, and now since we have enabled one additional Maven action, so it is now downloading all the dependent libraries that are required to get or to generate that coverage report. Now, while this works, let's get back into the container and just clear out this screen first, and then we will log in inside the same container just like we did previously, getting a bash shell. And here we can again go to the Jenkins home directory, workspace folder, and like the other two, even we have a test coverage folder now. So here, so once this executes, basically what is expected out of this execution is that in the target folder site, okay, the site folder has still not been created because the plugin actually, the Maven action has actually not executed yet. Jenkins is still downloading the various dependencies that it needs to run this action. So probably it will take a few more seconds before it is done and the action is executed. So it is downloading all the jar files here, which are the dependencies for this action. Above we can see that it downloaded the Kobershara jar file. Probably this will include the Java class code that will eventually get executed as part of that Maven action that we have in place. And in the meantime, we can go ahead and install another plugin to have a pipeline view of these three jobs, and then we can define the dependency or the order of execution of the test job to run after compile and test coverage job to run after test. That way we can have a well-defined pipeline that could then trigger to any change that we do on the source project. So if I click on plus, here you see that we have only two views, list view and my view. Now in addition to that, we need a pipeline view here. Now since that is not enabled, and as I discussed about the Jenkins behavior before, to get that feature working, we'll need to install another plugin. And in the meantime, we see that the test coverage build has passed. So I'll just proceed with the pipeline view plugin installation, and then maybe in the Docker container, we can just have a look on how or where the report has actually been created. So I go to manage plugins again, go to the available tab, and here I search for build pipeline and I proceed for the installation for this one. This again has some dependencies on Javadoc, Maven integration, and some other libraries like jQuery, build pipeline. Probably jQuery is needed because it needs to generate HTML with the with the jQuery code, so that we can actually interact with that report when it is published on the project page. So while it executes this, let's get back to the Docker container. And previously we were in the test coverage project inside the target folder, and it only had, so inside the target folder we can see that the Kobershara folder has now been created. So if we go inside that, I'm sorry, so it was the site directory, and inside that we had the coverage subfolder. So this contains the coverage.xml report. So now if I get back to the Jenkins dashboard, we can see that the pipeline plugins in the meantime have succeeded. Let's get back to the dashboard, check test coverage. So here we can see that we get this nice view, which basically tells us or gives us an idea about the Java code of a repository, how many packages are there, are the 100% code covered, unit test coverage completion is basically listed down in all of these. So once this is done, and since we have also installed the pipeline plugin now, let's get back to the main screen, click on the plus icon, and as you can see, we have the pipeline view now. So here I can just name this pipeline as the test project pipeline, and we will create a build pipeline view. So in this, basically most of the default options are good enough to continue with, but you could customize them as per your need. How many build displays you want to see, and what is the refresh frequency for this view, and things like that. So the most important configuration here is the first job that this pipeline will execute. So for this, we can we can select the compile job, and I click on apply and OK. And now you can see that on the build pipeline page, we see the first job compile to be present here. Now similarly, we could also configure the test job to automatically automatically run once the compile job is successfully finished. So we could select any of these options, but let's go ahead with a stable build. And like we did for the test, similarly, let's do this change for the test coverage also. So inside the test coverage configuration page, let's define the dependency to be on the test project and click on apply and save. Now, if I get back to the pipeline view, here you can see that we have 3 different jobs listed down, and they will execute in the same sequence. Now, one more addition that we could do at this point of time is configure the compile project to check if there are any changes on the GitHub repository master branch which needs to be built. And for this, we can just click on this whole SCM option. So schedule, it takes in a cron expression. So we could check for such occurrences every minute. Once we save this, Jenkins will just give us a warning saying that this would trigger every minute, because that is a bit frequent. That is a high frequency event to test for changes, and normally code changes don't come in that frequently. But just for the sake of demo, and to see the pipeline in execution, I'll just click on apply and then save. So at this point, the compile job is regularly checking this particular repository for any new changes that might have come in. So let's go ahead and clone this repository on my local system so that we could do some minor change and push the code. So at this point, I can just do a git clone. Let's get inside this simple Java Maven app. Maybe we can do a quick change in the README file. Okay, it looks like the executables vim and vi are probably not there in this Docker image. Maybe I could have installed it when I created the Docker image by forking the Jenkins CI latest stable release. So one other thing that we could do is I'll directly go on the GitHub portal, and here maybe we could directly do a change. So I can just do a minor change to the project and click on commit. So now you can see that the latest commit is now 0807188, and what is expected out of the compilation job now is that it should keep monitoring the Maven app repository for any changes, and then automatically execute as in when it finds some new revisions that need to be built. So here you can see that this build automatically triggered, and let's go to the pipeline now. And once this is green, it just triggers initiation of the other job, that is the test. So now this is the pipeline view basically, and this is how we achieve the entire integration or automation with the end repository that is there on GitHub. So maybe I can do a page refresh to see. Yeah, so the test build, even that is green now, and now currently it is going on ahead with the test coverage. So even that is green. Yeah. So if I go ahead to test coverage, I can just go to the main dashboard, and I can see that all the packages in the classes coverage has been listed down here. So I hope that gives you a good idea about how the integration is achieved with the help of Jenkins, and how we can achieve automation. And there could be further plugins that could be integrated post this stage, and you could have multiple email notifications or things like that, whatever custom behavior that you might want to build upon. And these cases and these scenarios could pretty much vary from team to team. So some team might have some specific requirement. You could have a nightly build which just triggers and just sends out a report on some email ID, but that is probably out of scope for the agenda for today. So that's all for the demo.